Hey everybody, Mrs. Herman here. I'm going to try my hand at my own ed puzzle today, so we'll see how this goes. You learned yesterday about the basics of probability, and we're going to dive into a little bit more of that today. So our goal today is that you can explain what happens to probability when the sample space is changed by multiplication, okay? And that'll mean a little bit more to us as we get through this lesson. So we're going to start right with problem 75. Okay, I went ahead, so this says, your team will be given a bag containing a set of colored blocks or counters. Don't worry about that link in here. We're just going to all assume we all have the exact same amount of blocks in our bag. So if this were class, I'd have a bag or a bin where you couldn't see these, but there'd be the same amount in everybody's. I drew it on here. You can pause this video if you'd like to draw it on yours. You guys know by now I'm a super visual learner, so I need to see it in front of me. So there's my yellow, 2 reds, 4 greens, 5 blues for a total of 12 blocks. So it says, look at the blocks in your bag. If you were to reach into the bag and select one block without looking, what is the likelihood that it would be? I'm going to be honest, I don't like that they use the word likelihood. When you hear likelihood, you're using words to describe it. So let me take a little second here. If we think about like a number line here, and when we talk about likelihood, it falls between a 0 and a 1. If you're talking about 0 in probability, when I'm listing probability, that would be 0%. That means it is something impossible to happen. Impossible, will never happen, okay? There are many events that that's the case. For example, I'm going to wake up, what's the probability that's going to be 1999 when I wake up tomorrow? Well, that's impossible. And I know you guys don't get into like the whole, well, what if sort of thing. It's either like based on the facts, it is not going to be 1999 ever when I wake up tomorrow. So it's impossible. 0% chance. Going all the way over to the 1, that would be a 100% chance. It is going to happen. Okay, those are going to be certain types of events. For example, I flip a regular quarter and it's going to land on heads or tails 100% of the time because those are my only two choices. Okay. Then right in the middle, that's going to be your 50%, okay, or our 50-50 or 1/2, okay, so something that would be equally likely to happen. And then sometimes you're going to have, so we use these words, impossible, 50-50, certain. Over here you might have less likely. Over here you might have more likely. And you might see some other words sprinkled in between there, like extremely likely, extremely unlikely. Less certain, more certain. So a lot of those things are going to describe the chances of something happening. That is likelihood. When I ask you for the likelihood of something, I'm asking you for these words up here. That's what I don't like in this lesson, is that they use the word likelihood. So I'm going to cross that out, and we're actually going to say, what's the probability? Because I want the numbers. I want the percent or the fraction or the decimal that describes theoretically what should be happening. So the probability of me pulling out a red block. So the way we write that is a capital P, and you're going to see in parentheses, you saw this on the con video yesterday, that the probability of, and in the parentheses is the event. So I'm going to put the probability that I'm going to pick out a red marble, or sorry, blocks. We're talking blocks. So the denominator is always the total. There are 12 total blocks, and how many of the reds are there? That's my numerator. It is 2. So my probability is going to be 2/12, or, as always, simplify whenever possible, or 1/6. My probability of picking a red block is 1/6. Then I'm going to go for green. My probability of green, again, it's out of 12, but this time there are 4 green blocks. So that's going to represent 1/3. Let's go ahead and do the probability of blue. Again, that's out of 12, and there are 5 of them, and that one cannot be simplified. It is also fine if you are expressing these as percents or decimals as well. Just go ahead and round them to the nearest hundredth if you are doing that. And then again, probability of orange. So there are still 12 different blocks in there, but are there any oranges? Nope. So that's a 0 out of 12. That is an example. If I would say likelihood, like up here, that is impossible because there is not an orange block. So that is not going to happen at all. All right, so I want you guys to kind of pause and think about, do your answers for part A represent theoretical or experimental probabilities? So real quick, think theoretical is based on the facts in front of you, kind of the math behind it, what's the probability? Experimental probability would be if we were to actually do this experiment. If I said, okay, do this 50 times and record your results, and then let's say 50 times, 10 times I pulled a red block, my probability would be 10 out of 50 because it's based on the experiment that I did. So based on these numbers that we have above, do you think that represents theoretical or experimental probability? All right, hopefully you chose theoretical. Because it is based on the blocks that are in there, how many are in there. I've not done the experiment yet, so that's going to be theoretical probability. We're then going to move on to 176. If you were to select one block from the bag 12 times, and I put that block that I took out back in every time, so I didn't leave it out, I put it back in, how many of those times would you expect to have selected a blue block? What if you drew 24 times? Okay, so obviously we can't discuss this because we're not together in our teams, but this is where probability helps us with predicting. We use our theoretical probability to help us make predictions based on the math, based on the facts. So because there are, remember in my picture, the probability of blue, okay, and this is first, remember there's two questions here. So if I were to do this 12 times, okay, I would expect to pull that out 5 times because there's 5 of them, okay? Then it wants to know, well, what if it's out of 24? All right, if I'm trying to figure that out 24, well, I'm just going to do equivalent fractions here. Now my denominator is out of 24, and so I'm just going to go ahead and double my numerator, and I'm going to get 10. So my fraction for 24 draws would be 10/24, okay? I would think I would pull a blue block 10 out of the 24 times. All right, so that's the difference between those two. Last but not least, so here's where that goal of this lesson comes into play with 177, doubling bags, and it's exactly what it sounds like. We're going to double those bags. So now imagine you and another person combine your blocks together, okay? So if we kind of go back up here, now, remember, I'm super visual, I need to see it. Now you don't have one yellow block, you have 2. Now you have 4 reds. Now you're going to have, bear with me here, 8 greens. Oh, and 10 blues. Okay, for a total of 24 blocks. Okay, so it says, do you think the larger sample space, so my sample space is what I have in the bag. Before my sample space was 12 blocks. Now my sample space is 24 blocks. Do you think the larger sample space will change the likelihood of drawing blocks of different colors? What do you think? Okay, a lot of people sometimes think that, oh, well, you doubled the amount of blocks, you're going to double your probability. But we just proved up here, which is why they asked this question, that it really is just making equivalent fractions. Yeah, my denominator's getting bigger, but so is my numerator. I've doubled my number of blocks, but I've also doubled the amount of blue blocks. So it's staying proportional. They are still equal to each other, okay? So I don't have any greater chances than I did when I only had 12 blocks because I didn't change the amount of blue blocks to total compared to what I did when I had 12. So my answer here is going to be no, it does not change it. Okay. All right, for B, it says, get a second bag of blocks from your teacher. So pretend you've got a second bag of blocks, okay, and combine it with both bags. So it's going to look like my picture above. How many total blocks are there in the bag now? Well, we've already kind of answered that, 24 blocks. How many of each color? Okay, so yellow was 2, red was 4, and I write this down too, guys. Green was 8, and blue was, what was that, 10. Let me add those up really quick. And yep, that gets me to 24. Okay, Work with your team to find the theoretical probability for selecting each color of block in the combined bags. So we're going to go ahead and label this. My probability of yellow, probability of red, my probability of green, and my probability of blue. So let's do a couple together, and then I'm going to ask you a question about one of these. So let's go ahead and the probability of yellow. So now it's out of 24, and there are 2 of them. So when I simplify that, what do you know? I have the same one from above. Probability of green. There are 8 of them out of the 24. So that still is going to give me 1/3. So we are proving, even if you double the bags, triple, whatever, it's not going to change the probability. Go ahead and try and figure out what the probability of red is going to be. Yep, out of 24, there are 4 of them, so that's going to be 1/6. And then probability of blue out of 24, that's 10. Okay, so we know that's going to be 5/12. So there's my 4 theoretical probabilities. I've not conducted an experiment yet. Has the probability for drawing each different colored block changed? No, it is not. They are all the same. Okay. We're going to go ahead. It says how, well, let's scroll down to letter E right now. We're going to kind of skip these 2 for now. The last one we're going to talk about, if you were to make 12 draws, so pulling a block out every time, and you replace the block back between draws, how many times would you expect to draw a blue block? Go ahead and tell me what you think right there. Okay, for our blue block, I would expect my probability of pulling a blue block, okay, is still going to be 5 out of 12 because there are 5 blue blocks out of 12 total, and I'm doing that 12 times. All right, I hope this helped you guys, and we're going to do a little bit more with probability.